going to get started again from the break. Hi, I'm Rich Lappenbusch with Supermicro, and I'm serving currently as the Immersion Warranty Guidelines Chair. In that role, I lead out a group of companies and individuals who volunteer in the Immersion Warranty Guidelines workstream. And together for the past year, we've been discussing the issues of warranty with a focus on IT equipment, specifically in the use case of immersion cooling. And I'm going to share with you the readout and the output of some of those discussions over the past year. All right, we'll do it that way. So, one of the most critical things is understanding where warranty fits into a larger picture. And so I want to draw the larger picture and try to walk you around all the things that are happening around a warranty before we kind of dive right into it. Along the top, we have a number of international standards organizations, national standards organizations, industry standards organizations, policy groups, research groups. A wide variety of input comes into a funnel. And that funnel of people and organizations drives a set of expectations about how IT equipment and their warranties will operate in real-world conditions and real-world scenarios. It doesn't necessarily define it because a warranty, by definition, is a legal promise within a sales contract, but it suggests an expectation. And then, obviously, you guys aren't seeing that. One moment. No? There we go. So as we go clockwise around here, you'll see that effectively for the IT equipment, it needs Ethernet, AC power, DC power, or sometimes both. And you'll have a set of equipment, components, network interface cards, cables, solutions, liquids, and somewhere on the right-hand side of this bubble called components, which is inclusive of the equipment, inclusive of the liquids, and inclusive of all the components on both the boards as well as the things in the liquids, such as temperature sensors and other things happening in that space, is a set of a warrantyable condition. So there's an environment in which a warranty can be present. A lot of other things suggest what might happen there, including reliability, documentation, just generic business risks that are also happening at the same exact time, as well as the type of immersion cooling going on and the combinations that might exist of the different types of cooling that are going on. So at its most fundamental state, the warranty is a legal promise. It's part of a sales contract. It's protected by law in almost all countries, and it's very different from country to country because each country has defined what is warrantyable and under what conditions can that warranty be offered. That's why, when we get any piece of equipment, we have, 15 languages at the back, and that printout may be different depending on what country we source the material or the components or the system from. And so it's a promise to repair or replace it if it develops a fault, and a fault is defined by the manufacturer, not by the customer. So the fault is the condition in which the warranty will be enforced or enacted. In the context of that product sales activity, there's a statement of warranty. It's typically the last page or nearly the last page of your sales contract. After a BOM, after a sales contract, after your, all the other service conditions. And it will give you the condition, the functionality, the term, how long it's good for and under what conditions, and the lifespan. It varies greatly based on the legal venue you're in, time, use cases, and the seller to the owner directly. So we might talk a little bit about why do people seek warranty. And warranty has developed over time because people want to mitigate risk. It's not that they believe the product they're buying will fail. It's that they want to understand that if it does fail, that they have, without legal recourse or lawsuits or things like that, there is an immediate action and a contingent action that will happen upon purchasing this product. And that could be the failure of the component on the motherboard. That could be the failure of the entire system, say the whole motherboard itself. That could be the failure of the solution. Possibly a fluid goes bad or a temperature sensor shorts out and causes pollution within the fluid within the warranty condition of the immersion. Impacting this is a set of risks that are larger than the warranty itself, but important to consider when we think about immersion. Immersion is relatively new to almost all the users right now. And those risks start with the concern of product failures, that there'll be incompatibility or there'll be unacceptable errors, or the product will only last, say, a fraction of what it might last in air. So I had this type of product in the past, it lasted 3, 4, 5 years, and now I'm only getting 2 years of use out of it, things like that. There's also risks of ESG fines, that this product may not be compatible, may have too much embodied carbon, or may have chemicals, or it may have conditions that make this particular product out of condition or out of acceptability. And there's also a risk of just not enough data about immersion at all at this stage in time. I think we have done, as OCP, a really good job of getting a lot of data out there, but there's still not a critical mass of data where most of the customers feel confident that immersion cooling is ready to go and is completely figured out. A lot of variability across the different fluids, across the different operations, how things operate, pumps, tubes, connectors, junctions, you name it. There's a lot in one of these systems. There's also just a general logistical complexity. So most of the immersion systems and solutions, when completed, have just simply more parts than the average air-cooled rack today. And that's because a lot of that cooling is masked from the IT users. That's out in the other part of the data center that most people don't see and typically don't have to deal with. And then finally, there's also lawsuits and all the other issues that can happen. So compounding all this is the CPU growth. We know that CPU wattage, or the TDP, is growing at a compound annual growth rate of about 19% over the past 4 years. We know GPUs are running at about the same rate. Actually, depending on what roadmap you're looking at, that's gone up in the past month or two, so it's probably over 19% right now. And then global power costs are up, growing at about 13%. Now, the power costs are a tough one because a lot of people have long-term power contracts, so that doesn't impact them. But it does impact the general market. So these are general market conditions influencing the issues of warranty. And so downtime costs a lot more than it did even just a few years ago. And the quantity of coolants, last year we had dozens of coolants. This year we've surpassed over 100 coolants, immersion coolants in market and available for sale and use. So just the testing matrix for over 100 coolants is incredible. We also want to call out that the network port size, the size of the network, is growing immensely. So we've come up with a single diagram to give you a suggested process of how we think developing warranties will work well. And that is, starting on the left, to do material compatibility testing within individualized components and individualized products. And then once those have been tested, with a given coolant and a given use case, doing compound tests or performance capability tests in which it could be the fluid plus the tank plus the candidate ITE equipment. And then once it passes that, then moving to more reliability testing, which may be accelerated. So you may heat up the tank a little bit more than is normally considered. There's a lot of different ways to do reliability testing. Can do with temperature, pressure, whole entire line of thought there. And then finally, that should all drive a warranty risk assessment or a manufacturer's estimate of what they might see in the failure rates or annualized failure rates of their products. And from that odds, if you will, the odds of failure, a manufacturer has the option to determine whether they want to offer warranty terms and conditions, which in most organizations say offer something. Now in Immersion, about half the manufacturers have accepted that Immersion is a use case, and the other half have not yet said these are air-cooled components that are being retrofitted for another condition. So there's the school of thought is still out on exactly how that's going to play out. This process here is proven over many other industries. This is not unique to IT, but it's something that we've grafted from a number of other industries to give us a process, a flow that we think will be helpful. So the best practice in drafting your warranty or thinking about offering warranties is to map all your risks and build your own internal corporate tolerances on how much risk is acceptable. The second is to build data to support your mitigations to those risks. Warranty is not the only way to solve the problem. It might be restricting, say, the types of fluids or the type of temperature ranges you do and other things like that. We believe using a standardized OCP glossary, just the terminology, if we can all agree on the same terminology, that'd be very helpful. And using the UN established codes for the components that are actually in the solution. So your local customs agents know these codes very well. They're particular codes, and I'll show you an example of these here shortly. So we have a glossary. It's available out on Google Drive, and you guys can get that. We have these commodity codes that we've grafted from the UN. And finally, we've created a matrix of the two so you can understand the different people involved in building warranties. And all of this is available within the work group in the version 1.0. And there is the document right there. It's available to all of you when you log in. So I encourage you to read that white paper and the specifications and the supporting documents there. I think they'll be helpful. And consider your own collective risks. And finally, shameless plug for Samantha Yates and what she's going to offer in the next OCP session, which is all about thermochemical reliability, which is kind of that middle of that process and what Intel's willing to share. They're still doing the work, so I look forward to seeing her presentation at the next OCP. So thank you for your time.